With the proliferation of distributed generation, most notably rooftop solar, along with others, and the increasing opportunities for distributed energy storage, as well as other grid assets, utilities are more and more facing real situations where they have to deal with reverse power flows, with increased voltage feeder voltage levels. And DERMS offers somewhat of a solution towards that, or increased visibility. And I'm delighted to, well, my name is Omar Saadeh, Senior Research Analyst here at GTM Research. I'm extremely excited to have these DERMS professionals on my panel. One, because the subject of my research is actually DERMS. And two, I've talked with all of them individually, and they all have extremely exciting things to share. Tom Bialik on the left, Chief Engineer at SDG&E, our host utility. Arinda Maitra, Principal Technical Lead at EPRI. Oliver Pacific, the CTO at Spire. Ed Hedges, Manager of Smart Grid Technology Planning at KCP&L. And Adrian Tuck, the CEO of Tendril. I wanted to know if you gentlemen could maybe kick this off by explaining a bit about your roles in your respective companies, as well as what excites you about the decentralization and more so the distributed nature of our present grid. Tom, do you mind starting off?
Sure, no problem. So, as I said, I'm really the Chief Engineer of San Diego Gas and Electric, really looking at grid modernization. What is the strategy and policy around T&D infrastructure solutions, looking at distributed energy resources, and also looking at it from a customer perspective. How do we empower customers to make intelligent choices about their electricity use so that they can manage their energy consumption as they see fit? I think for those of you that were here before and sat through the Smart Inverter panel, I would say what's really exciting from our perspective is the reality is that, oh, by the way, get over it, smart inverters are here. We need to use them, we need to leverage them. And from a utility perspective, at SDG&E, that's one of the reasons we want a DERMS package. And we're looking at DERMS. So the real exciting things are really about the ability of a utility or any provider to be able to actually use technology to control things at a more granular level than what previously we had the capabilities to do. So, sure.
Hi, I'm Arinda Maitra. I work at EPRI. My basic background is in distribution, but for the last 10 years, I've been working on electric vehicles, energy storage, photovoltaic, primarily from an integration. And a lot of the discussions that we had been having today, how do you integrate these systems? You know, what role does the utility play? What are the controls? Those are the type of activities that I'm heavily involved with in EPRI and in the overall society.
I'm Oliver Pacific with Spire. My background is in power generation, and the last 10 years really around distributed energy resource management. Back in the day when we didn't know what to call it, and we called it microgrid or something else, was really active controls in the distribution system, very similar to what you may have at the transmission level, but actually in a much more complicated network, and with a really high volume of resources, and really in a distributed nature. And so that's been our work for the last 10 years, really building up our platform to really get to the point where we're at today, where we can start delivering those products and services to different utilities or end users.
I'm going to date myself, and when I graduated from college, we had just kind of come out of the first oil embargo, and renewables and windmills and solar was just being talked about, and automation. I think 250 watts was a big device that we were trying to interconnect, but we couldn't make all that work because of the lack of standards and communication technologies and other things. So it's been something that I've dabbled with my whole career, and our company applied for a demonstration grant, and we took the opportunity to look forward down the road, 15, 20 years, say what kind of control systems do we need in place to be able to manage all this. A lot of work had gone on the grid edge devices, but how are we going to manage all this with our back office automation and control systems? And so we put together a project to try to deploy about 8 different back office systems using, say, current technology. It was current technology 5 years ago to try to manage, the next generation grid and identify some of the technology gaps. So it's been pretty exciting to see where we're at, and we're just winding that up now. And I can see the next horizon coming. It's even more automation than what we envisioned at the time.
So my name's Adrian Tuck. I'm the CEO of Tendril. We've spent the last 8 years helping utilities think about the people and things that sit on the other side of the meter and how to communicate with those in order to derive customer satisfaction, efficiency, load control, and so on. So I come from that sort of background. Prior to this, I founded a company called Ember, which invented the wireless standard Zigbee. For those of you who like Zigbee, you're welcome. For those of you who don't, it was somebody else.
All right, thank you. In the opening session of the Grid Edge Live conference, the CEO of O-Power, Dan Yates, stated that utilities love their grids, and rightfully so, since they've invested so heavily in them in the past, billions of dollars. However, they haven't addressed really the pressing issues on the distribution grid with the proliferation of DG and other resources. Arindam, you've authored several papers on DERMS through EPRI. To those in the audience that might not be so familiar with DERMS, what is DERMS and what does it offer distribution utilities?
Yeah, so that's $1 million question, and I'm not sure if we will have that answer resolved after an hour. The main reason is, I think, and this goes back to last year, when I was telling my father-in-law, he came to visit me, and I was telling him about PV, and there's a lot of PV penetrations. And he said, "You said the same thing when you married my daughter." And I said, "Yeah, but things are happening now. When I was telling you, it was all our research, right?" So my point is, there's a lot of work that, as Tom, you mentioned, especially with PVs and storage, there's a lot of work going on for several years, and the adoption into the utility system has been slow. And the reason behind this is the way every utility, and we have a lot of utilities across US, the planning and operations are different. The behavior, depending on the type of feeders, the characteristics are different. So the adoption changes. Like, for example, what Tom and Southern California Edison and PG&E has, as opposed to what you see in Southern Company, for example, or TVA, the system characteristics are different. So I think, and I think you also heard Jason Handel mention that Duke is heavily interested, as well as Georgia Power, in investigating VoltVar, investigating using DMS and DERMS, and seeing how we can have all these aggregated resource kind of communicate at one place, and then eventually talk to what we call as distribution management system. And the reason why I said it is going to be difficult to come up with one answer is a lot of utilities do not have DMS. Some utilities have OMS. Some utilities have some pilots of DMS. So I think we all understand the technology. We all understand that the controls are coming together. But the actual implementation and how it is going to be implemented within a utility environment, especially for operations, will take time for adoption.
Definitely agree. At GTM Research, we've come up with a very broad definition of what a DERMS is. And I mean, let me know if we're wrong here, but what we're seeing is that it is the software platform to increase the visibility, the operator's visibility into their distributed energy resources, what they may be. I'm curious, on a utility point of view, either Tom or Ed, what are the challenges that you guys are facing on the distribution, on the last mile distribution? And I guess since you do have DERMS deployments, whether that be a pilot project or a full-out plan to deploy DERMS, how do you use that to mitigate those effects?
Well, I would say that one of the reasons why we're, as you can see, fairly aggressive on DERMS deployment is the fact that we already are seeing things like 270 megawatts worth of rooftop PV, 37,000 installations. We expect that to double by 2015. We see the numbers just going through the roof, doubling every year, or every other year. How do we control that? How do we control that in a fashion that we can now do it more cost effectively than, as a utility going back after the fact and putting in additional infrastructure? And that's really part of the challenge, and that's sort of where DERMS comes in. It's really a system that allows us to have some visibility into the distribution system, allow us to look at what's really going on, allow us to look at it a little bit more holistically. How can we leverage customers' systems? How can we provide customers information? Adrian's talked about what Tendrill's doing. How can we give them pricing information as an example so that they could actually respond to help us in times that we need grid support? And that's really what DERMS is all about. It's really all about sort of bringing these pieces together and looking at ultimately optimizing their performance of the grid and trying to make this move forward.
Ed, you guys have a very different profile, as in I'm not sure if your PV penetration is as profound as over here in San Diego.
No, it's not. But we definitely see in our future that demand response and demand side management along with solar is going to be very integral to meeting our needs. So in our perspective, we want to have one platform that gives us visibility to all those load reduction resources, whether it's demand response or distributed generation that's controllable, and be able to give those either direct load control signals or pricing signals to different customers, because different customers are going to react differently and want to participate in a multitude of programs. There's not going to be one program that fits all. And all these resources have different financial impacts to the utility. And our project, we tied our DERMS system, which knew everything about all the resources and all the programs and where they were located, with our distribution management system, so that when we had localized congestion, it could request and the DERMS would figure out which resources to call on a small geographic area, which is a big change for us. We've had demand response programs and things in our company, but they're system-wide. They're for generation load reduction, but we see the need for localized management of those resources in small geographic areas, and we feel the DERM gives us the ability to do that and to call on the most cost-effective resources at any given time.
Okay, Oliver and Adrian, I'll promise to get to you guys. I just have another high-level sort of question. At GTM Research, we track a lot of the DERM deployments, or what we've defined as DERMs, and we're seeing a very different trend approach here in North America as opposed to Europe. I wonder, Arindam, if you could maybe talk to us about the ability over here in North America for DERMs as opposed to there in Europe, and even maybe in Japan, where they sort of are using a micro DMS approach.
Yeah, so this goes back, and all throughout the day today, we heard about Germany, right? But then we should also say, although Italy dropped out, by the way, from the World Cup, they were eliminated today. Our next point should be Italy, because they have about 63% of PV penetration. They already have a full-blown DMS system implemented. They already have these aggregations, I was there last week, and I was talking to NL, which is the biggest utility provider, and I was asking them, how do you do the communication? So it's like going back to what Ed said, right? So the way we in EPRI are kind of looking at our US scenario, we look at this with respect to low penetration scenarios and high penetration scenarios. For example, in Tom's case, Tom is in high penetration. HECO is in high penetration. So there, things are already happening. You already have a penetration way up. So you're not going to start spending the whole day talking about smart inverter. You will start talking about controlling them. And if you go back to TVA land or some others, where they are kind of really trying, like for TVA, for example, they are really trying to make that valley, greener, if I may. And I'm hoping no one from TVA is there, so otherwise I'll be in trouble. Where they are really looking at smart inverter, autonomous controls. So I think this is where the fundamental difference between US and Europe is, where Europe is probably already way up there in the high penetration. They already have DMS. Now it's all about aggregating, as Ed and Tom mentioned. It's how do you aggregate them, because without that, you cannot do DMS in a functional way.
Okay, Oliver, you guys at Spire have quite a lot of exposure here in North America in the microgrid area in hierarchical layered controls, but you also have that presence in Europe, whether that be in Denmark and other projects. How does DERMS fit into the microgrid or the virtual power plant kind of the trends, and where do you guys play in that?
Well, we think of it as one and the same. Back 10 years ago when we started our project in Denmark, the cell controller project, we didn't know what the term was. And we were looking at high penetration wind. At that time, Denmark had about 28% penetration from wind. And it was all in the distribution system. So it was in the 10 kV distribution system, and they had high penetration of CHP in each town. And they went through some issues where they had outages. And so what they were looking at was, how do we couple the CHPs and the wind turbines under one control system? So it started out as a microgrid project, and it grew into volt-var control, markets, VPP. So we layered different technologies on as we grew the project. And it was really the basis for Denmark, and I think a lot of Europe, in their thinking on that next generation of control to get them to, Denmark has a goal of carbon neutral by 2050, including transportation, which is just an unbelievable goal. They will, by 2025, probably hit over 50% penetration of renewables from a total energy perspective. So they really are trying to lead the way. Europe, in some areas, is really leading that way.
Okay. Also, your approach, your control approach, which really pushes intelligence to the grid edge, to the end nodes, how does that differ with other approaches where you have a more centralized, and is that essential to DERMS?
Well, we believe so, okay. Since that's sort of what we bet our differentiator on, was really that distributed hierarchical nature of the control system and moving intelligence out to the devices as far as we can. So it really becomes a question of cost. So if you are moving down to a 5 kilowatt rooftop solar, what is the related cost from a utility perspective that you can afford to put out there? And I don't know that the business case is all worked out for that yet. And we're really looking at those things. So some changes in technology, really reducing the cost of those smart nodes. But that is really where we see the intelligence is sort of from the bottom up. And that's kind of how we started approaching the problem originally in Europe, was really from the bottom, the interfaces down to the wind turbines, to the CHPs, to the solar, and the loads, and then sort of bringing that up from a operational perspective to look at optimization and those kind of things.
Okay, and so looking at the end users, looking at a customer's perspective at this, and tying in various things like distributed, rooftop, tying in home energy management systems. How does DERMS, Adrian, this is probably directed to you best, how does DERMS affect the end user and their perspective?
So, well, I think firstly we should pause and acknowledge that the two utility executives on the panel, Tom and Ed, the first thing they mentioned when they talked about DERMS was the customer. So, that's a real mark of progress forward. I think if we had been having this conversation 5 years ago, that wouldn't have been the case. And so we should all pause and recognize that the customer is moving to the forefront. So two-part answer. The first thing is that, as the grid has evolved, up until now, mostly the planning and resource planning around it has been largely centralized. That doesn't mean that everything that's on the grid is centralized. It means that the utility has controlled the rate and location at which assets have been distributed. So now we find ourselves in the point where a customer's decision to put a solar panel on a roof, buy an electric car, is not something that's in the control of the utility. And so we've moved into a model where we're now having to predict and react to changes in customer behavior in ways that are very, very difficult to do using historical methods. And so all of these new tools have to factor that kind of thing in. And secondly, I think we all have to be fairly humble about our ability to predict not just who is going to buy what, but what are they going to buy, and at what and what capabilities will they have. I think if we'd all been sitting here 5 years ago predicting solar, we would have all had different views about what that curve looks like. We'll all have views of what EV take-up will look like, and we'll all be wrong. That's the one consistent thing here. And so these systems are going to have to be able to react to changes in pace. And actually, I think there are products and services that we have not yet conceived of that will emerge. And I tend to use the example when I talk about this about internet parallels, where the minute somebody started to allow the ability to download music, people started to share music at the edges of the network in peer-to-peer relationships. The minute you provide this kind of connectivity to customers, people will start to conceive of models where I'm going to sell my access to my next door neighbor, and we can all argue about which way the electrons flow, but from a customer perspective, they'll start to think of new business models and new opportunities that we collectively, I think, have not yet conceived of. And so this whole system has to take all of that into account. It has to use open standards. It has to allow customers to continue to make choices at the pace and rate at which they choose, rather than in some pre-subscribed model that we think of.
Yeah, especially as I went through the research, interoperability is key. However, when we talk about demand-side management side, the demand side of DERMS, it's often acknowledged that it's offsetting in intermittencies from, for example, a large amount of renewable generation. But it's also other things. I'm wondering, at KCP&L, what's the primary use of your DERMS system?
Ours is, right now it's focused on doing a lot of demand response and sending signals to the various. We have a hierarchical control scheme, and that's one of the complications with how you define DERMS is which class of DERM are you talking about? Are you talking about one that's actively controlling the generation, or are you one that's more sending pricing signals and negotiating things between very disparate types of systems? We're using it based on congestion signals from our DMS to send event signals to charge management system to Tendril for the home, to where it could either be a direct load control or it could be a pricing signal where the customer would set their preferences within that home energy management system on how they want to react. The utility may not have control of that, of all these resources. So some of this will be incentive-based, signal-based, and we'll use the AMI system to see how the customer actually performed under that, and then learn over time how to expect each individual customer to perform. We also have a grid battery that we talk back and dispatch that battery on the grid back to our DMS. It's the control authority for the grid. And we see those channels of communications for these events just exploding. You've got Comcast, Time Warner, you can buy all these home automation gadgets through them. People will be bringing their devices, and they may participate in our programs, and there'll be a multitude of communication channels. And we feel our DERM needs to be able to coordinate and orchestrate all those various channels at the high level DERM that's making these economic decisions. There'll be lower level versions of management control that are working in small regions to help with sustainability of the system when storms go through and things like that might island and coordinate and island themselves. That's another level and class of DERM, distribution energy control. So
a simple question. When I was often confused about this, what's the difference between a DR-driven DERMS and a DRMS, a demand response management system?
We discussed you asked this question.
that's the 64th. I think some people are using demand response systems as siloed system to initiate demand response programs. And they're using DERM systems to manage distributed resources. And there's a set of functionality that's very common to both of those, and if you have two independent systems making decisions, you're not going to get the most economical decision or the most optimum for the utility. So our view is that, at least at the dispatch level, we need a common system that's determining which of those programs to initiate, and then we communicate those events to our demand response system that actually coordinates and orchestrates the demand response events to those customers, or to a grid or DER system that will actually manage and control the grid resources. So we've actually implemented maybe a higher level that's a combination selection system.
Okay, yeah, please.
One point to add, and we have seen it even within EPRI as well as in the utilities. Even now, the consensus about DERMS and DRMS, they are treated separately. And I think, Ed, your statement is right on, and I think the basic logic was the DR portion, in essence, evaluated from the energy efficiency programs, whether it's in the utility sector or in the vendor space, and that's how that cloud came in, where it was a separate DRMS cloud, which was outside the DERMS package. But in essence, it should be integrated together.
And I'd point out too that the reality is we've looked at this for a variety of reasons. If you look at DRMS as a product, that's really what exists for example, in California today. Whole pile of products around demand response that they're called at the grid level. Now you start looking at more granular locational type requirements, and then you say, well, how do I do that? So now I need a DRMS system. You can look at DRMS as a broader system, and it looks at all sorts of devices. It will control DR as well. But then you start saying, well, to answer one of your questions before, why is it distributed? Why is it hierarchical? And the answer is, we have this conversation all the time at work with some of our system architects, and say, we're not going to be able to build the Whopper. We're not going to be able to build this one big system that sits up front and actually gets down to and talks to and controls 160,000 endpoints, as an example, which is all the number of our distribution transformers. You're not going to get there. It's going to take too long, especially if you want to do much faster control. And so you need to go into that distributed federated hierarchical structure, and that's one of the reasons for it.
One of the things that this little bit of the conversation highlights is, for me, is that I think that there's an organizational challenge inside the utility, which is historically these things have been siloed. There have been EE programs and demand management programs and so on. And what we're hearing here is that this is a much more flexible, fluid approach to things turning up and consumers moving from one mode to another. And so I think the technology will move quickly to adapt to that kind of model. The question is, how quickly will organizational structures in the utility evolve to be able to support the fact that a customer might be a demand response customer and also a solar customer and may buy an EV and so on throughout the life cycle of the customer. And I think we at Tendril see inhibitors to deployment of these kind of solutions that are organizational as opposed to technological that have to be overcome.
Okay, and Tendril and Spire are quite small, not that large of companies. I think you guys at Spire are under 50 people.
Yeah.
Large grid incumbents that we've come across, like Alstom and Siemens, both offer DERMS solutions. Now, whether that's based because they're coming out of Europe and they have Germany to deal with an enormous amount of an influx of massive distributed solar. How do you guys go up against such large competition? and what's unique about that? I mean, you guys offer a very different architecture And how do you address the problems?
Well, I think the real issue for us is the platform and the flexibility of the platform and not being the incumbent. And so if you look at the way, let's say, a DMS is normally rolled out, you're talking about, $50 million, $100 million to roll out a DMS system. And we're really trying to take orders of magnitude out of that from a complete rollout perspective. So it's really about the flexibility and the cost savings. So really, as not one of the large guys, you really have to differentiate yourself in that fashion. And the utilities are driving a lot of that. As both Ed and Tom have said here, there will be differences in the way it's done in certain utilities. And so the platform really has to answer the question for that specific utility. It can't be just one size fits all. It's got to be flexible. So whether it's demand response or generation control, it's really got to be set up to handle that. And that's really the key. And I think the other piece is really those incumbents are trying to use existing platforms that don't necessarily scale to what the need of the utility is. And so instead of putting that research effort in and building something up for a market that doesn't quite exist yet, so we've had utility executives ask us, so why did you guys build this platform 5 years before anybody needs it, right?
Yeah.
And so that's but you've got to be looking ahead, and I can't say it was vision that got us there. It wasn't that we were predicting, it was we had utility partners who were driving us in that direction. So
on the subject of existing infrastructure or existing platforms, a lot of the DERMS systems seem to be implemented and they leverage other systems such as AMI, such as SCADA. For our utilities on the panel, do you guys, when you implement your DERMS solution, are you leveraging, and what applications are you using from AMI or SCADA?
So we view the DERMS product really as a peer to the DMS. So the DMS is the actual grid controller. It's the thing that the utilities use to operate the grid on a day-to-day basis. DERMS is a product that can now sit there and make suggestions to DMS. I know you've got some issues over here, given what we're seeing based upon some load flows. Can you, the DMS to say, can you help me out? And now DERMS can go away and sit there and try to figure out, can it help it out? And it would then, for us, our implementation, we're really looking to go directly into the DMS and then into SCADA to effectuate the controls. But you're now pulling load forecast and all sorts of other information from the AMI, the MDMS, to bring back into the NMS or to bring back into DERMS to sit there and say, what are the forecasts? Because at some point, when you start looking at much higher penetrations of renewables, et cetera, that becomes a challenge. So we see the voltage regulation schemes as we move forward in time being basically driven by weather and be driven by forecasts and being stochastic models, something very different than what we have historically done. And we're going to need all those different various pieces to bring into a system that can digest them and create a solution.
We have a very similar concept. It's basically a peer to the DMS or the distribution management system, which optimizes and controls the grid. And a third peer to that is the outage management system that basically manages all the outage and the restoration efforts and the reconfiguration of the system to restore power. I think one of the challenges that we have, I've just in some of the other discussions as we talk about how we're going to design our grid in the future and how we're going to put some of these power electronics out there. Well, when you start have outages and you start restoring power and switching the network around, that adds a whole nother level of complexity that nobody even mentioned in any of those other systems. So that's an additional challenge that we have. One point to your other question about dealing with the big boys, I guess. In 2009, we put together our application for these 8 systems that we wanted to put together in our demonstration project. And in the DERMS component, we had 3 vendors that basically bid, that we could even find that professed to even have such a product or thought they had a product, or PowerPoints that even mentioned a product along those lines. 2 of them are no longer in business. Fortunately, the one we selected is still in business at the time. But now almost everybody else, most of the major people that have outage systems or distribution management systems profess to have, you know, a DERMS system or are building a DERMS system. So it's something that is very new to our industry. The requirements for it, how we define it, are just emerging. We're still trying to figure out that. And just to put that in perspective, you know, that was only 5 years ago, but that was in 2009. The iPad had not even been introduced yet. That came in 2010. And you look how it's transformed our, you know, ourselves and how we work. So things are changing very rapidly in this. So.
Well, Oliver, do you want to add on to that?
One comment, and this goes back to what Tom and Ed mentioned. You know, the DERMS concept, and Tom, your point was right on. The main control and strategy really resides within DMS. And DERMS, it's basically an aggregator, and it will have some control, but eventually the main supervisory control lies in DMS. And I think this is the place where over time this architecture will evolve, you know, how utilities adopt, where, you know, some utilities might integrate DERMS within DMS. Some utilities might have DERMS talk to their enterprise bus, where it kind of, you know, merges with OMS. They might not have a full-fledged DMS, but it might be integrated within their OMS system, you know, which is talking to SCADA. So these requirements, I think, will evolve over time based on how they get adopted.
One thing you have to realize is utilities have a massive investment in their current systems and infrastructure, and we can't just change those out overnight. So for most utilities, it's augment and build on what you already have. So that's why you will start seeing people say, well, that's in this system in our company, or that's in this system. We're fighting that with our CIS because that was the first database that the company had, and everything got thrown in the original CISs, and now we're starting to break some of that. You know, it used to be our meter data management system, and now we're pulling that functionality out into a standalone system, but that's a major transformation in itself and cultural change within the utility because we're so oriented to that, all that being there together and to change that. So you'll see it pop up and be created in different areas and different companies based on where they've started and what they can leverage.
Yeah.
The one thing I'll say to that is there are a much higher number of utilities that don't have a DMS currently, and they have some form of SCADA or a minimal SCADA. And so if you look at the utilities that are 100,000 meters or less, there's a much higher number of those. And I think the DERMS product with its flexibility will help those guys meet the needs of the future. So that's one of the things, as a small company, we're targeting those types of utilities, munis and co-ops. And they really do need information, and they're much more in the black hole of technology. They don't have the staff that the larger utilities have from an IT perspective, and so they're looking at different hosted solutions. You know, we're working with Tendril in some of those cases. It's really it's all over the place out there. So you know, the big guys absolutely have to stay with the systems that they already have installed, but the opportunity is probably at the smaller utilities currently.
Yeah, please.
So as one of the survivors in this journey that we were just talking about, you know, I would say that, you know, to go back to your question about big guys versus small guys a little bit, historically, innovation doesn't come from big companies, right? Big companies sometimes buy innovative companies, but most innovation, with due respect to the big companies in the room, takes place in smaller companies. And I have been the CEO of 4 of those companies in different industries as we've sort of chosen to sort of evolve industries and evolve products. The thing that I've learned in this industry is the risk to small companies here is is that the pace of change is not as dramatic as it is in, say, for example, the early industry. I was in the telecoms industry. And so you've got, as an innovative company, a small company, the pace at which you innovate is your competitive advantage. We just heard about that. And so you're first to market with a product, and hopefully you have the team that can continue to innovate it. No utility needs to get a product out by Christmas. And so that means that there's this relentless march behind you of larger companies who are moving at perhaps a slower pace, but more akin to the utility technology adoption rate. And so the way around that, unfortunately for small companies here, is capital. So we, somebody asked me this morning, a partner was talking to me, and they said, what did you spend $100 million on over the last 5 years? Or 7 or 8 years, whatever it is. And it's this, it's the hard yards you need to do at the front end of this market to test things and try them and drive them. And so you need patient investors and deep capital at the table in order, as a small company, unless you're very, very lucky on timing, to survive in this market. And that's been a big learning for me in this process.
Okay, and we did touch upon many things just now. So when we look at a DERMS system and the potential, a lot of people would like to know, obviously, where is the potential for implementing one of these systems? And what are the inhibitors? Is it regulation that's holding back deployment? Is it a technical question? Is the vendor solution, I won't point this directly at you, but Oliver, but is it a technical question? Are the solutions out there adequate? Or is it a finance question? Is there not enough stimulus funding? Is there not enough dollars in the utility to invest in those?
I think it's more a business model question. I really do think it's the business model. Technology, I think that we've proven in demonstration projects, not just us, lots of companies have proven that this type of technology and doing this type of control in the distribution system is not a technology leap, and it's a good thing to do. Now, how do you pay for that? So how do you pay for curtailing solar? And we were talking about this earlier. I mean, in Denmark, we had this case where you're over-generating wind, and wind becomes negative pricing. So Denmark's having to pay Germany at one time to take it. Now, of course, Germany has the same problem with solar, and so now they've got to pay somebody else to take that, or you've got to have active control with negative pricing. So then the question becomes, who gets turned off, right? Who got to stay on, who gets turned off, or do you pay somebody for down regulation, right? So obviously, if you look at the large balancing authorities, they pay for up and down regulation. So now when you look at that as a holistic system through the distribution network, those are the things, the business model that needs to support it to make it feasible to roll it out.
Okay, I know we have a couple more minutes before opening the floor to questions, but when you look at these types of systems, controlling DERs, you can have it on a system-wide level, such as the DERMS system we've been talking about, but you could also have it on a very localized level, such as a microgrid. Arindam, we've had conversations, I've had the privilege of discussing this with you previously, but what's your outlook on the future of controlling DERs? Is it in small, modular, localized deployments, such as microgrids, or is it on the grid, system-wide deployment?
You know what my answer will be? It depends. But you know, I'm so happy you brought the microgrids, because last couple of conferences that I have gone, it seems like every panel is microgrid, 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 right? And
we have one tomorrow.
And we have one tomorrow. So I'm glad we are ending the session with microgrids. But I think this goes back to your point about business model, because what you are now showing is a grid-connected system, a grid-connected assets can also play a part in an islanded mode, right? And this is important because this is a mindset. I mean microgrid is not new. I mean we worked like 15 years ago on microgrids, right? But I think what is changing is, this goes back again to what Tom you mentioned. I mean, we have PVs, we have wind, in some places. There's a lot of interest from energy storage. The technologies are there. People are figuring out, the integration and controls. Now, how do you build multifunction business cases? And I think that's where, using this DERMS controller, whether it's at the local level or whether it's at a higher level, is dictated by the size of what you are controlling. And I think it is going to vary. So it's like, going back to our picture, we see this as like a bubble picture. So you can, in essence, control 5 homes, like say a zero net energy community. You can control 1 feeder. You can control group of feeders, and these are either in the grid connected mode as well as the islanded mode. And I think these discussions that we are having, I mean, people are implementing this or have pilots planned for it.
And I'll add to that. I recently had a conversation, and I won't name the financial institute, who was looking at financing some of these microgrid projects and call them DERMS projects. And the thing that came out of that conversation was we were talking about having to have different streams of revenue, right? So one piece of equipment, energy storage, I may need to have 2 or 3 different streams of revenue out of that. That was a barrier to the financial guys, right? So they want one stream of revenue that they can count on, right? And when you add the extra layers in there, it really complicates the financing from where currently the financing is at.
Yeah.
So these cases that we're talking about, from whether it's a microgrid or a community level microgrid or larger microgrids, all these assets we probably need to get multiple revenue streams out of, using them locally, using them at the system level, and that becomes a business case or a financial problem of getting that through.
I mean, I'd love to jump into a conversation right now on ROIs, and I'm sure that's going to come up with different points of view. But I'm being signaled in the back to take questions from the audience. So if someone wants to ask about ROIs, feel free. There in the back, please, someone with a microphone.
Very quick.
Hi, Carl Lennox, SunPower. I think this may be a good group for this question. So we talked a lot about various uses of DERMS and aggregation, essentially, of distributed resources. How do you, and I'm going to preface this question by maybe focusing it on load-related resources, because last time I checked, you didn't have to get an interconnection agreement to install an air conditioner or plug in your EV, whereas with other storage and solar, you may, and that gives you perhaps a higher level of visibility and perhaps control down the road. But in the context of load specifically, how do you think about the interaction of your DERMS system with third-party aggregated distributed resources that are being dispatched into like a bulk system market? How does that all play out in your mind?
Anyone want to take that?
Well, I can take that one. It is certainly in the context of what we think is DERMS as one of the sort of ultimate use cases for this system, the ability to actually aggregate and through a scheduling coordinator put it into markets. You can also look at it more from a much more granular level. I think we talked a little bit about that, where maybe at a particular substation level you do have a problem. And so you use that to send the appropriate signals, and we can debate what those appropriate signals are. And customers modify their behavior, and we avoid incapacity or an outage or some other type of problem that occurs. But it is a use case in the context of this, and I would just say that one of the reasons why historically loads have been, we've built the system to serve loads, and it was one of those things that's how we looked at the world. How we look at the world is changing. Customers are changing how we view the world, just because they're making choices. They're making choices to put solar on their roof. They're making choices to buy an electric vehicle. They don't come to us to do those things. And at the end of the day, we are the ones that ultimately are trying to provide reliable service, keeping voltage within tolerance, and matching load and generation. And in order to do that, we need flexible systems. And I think what you're going to see, at least from our perspective, is that it's not going to be this one big monolithic system that sits back in our case, in our mission control center.
One of the To add on to that, aggregation on distributed generation, I guess, has, especially at the distribution level, has some challenges that you don't have with aggregated demand response. Because in our existing grid, demand response or load reduction is a reduction of load, and we can all handle that. You know, that happens every night, load reduces and that. But when you start talking about generation, and you're basically wheeling across a distribution grid, and you just can't, will be challenges if an aggregator could turn on this distributed generation to sell it into the wholesale market. You don't even do that in the transmission. You got to get reservations on the transmission grid to be able to transport, you know, to transport from one power plant to another, one wind farm to another. That's all got to be kind of controlled and dispatched for grid reliability. We're going to have those same issues as in the distribution. We may end up with a distribution market of some sort that parallels the wholesale market, just so you can do those exchanges and that approval process at the distribution grid level for exchanges, you know, down the road. If you got one microgrid operator at a campus wanting to, you know, sell power to or work together with another microgrid across town, the distribution grid has to be able to accommodate that, and that all has to be, there has to be a process for that.
The grid edge market.
Yeah.
We kind of call it grid-friendly services. So it's really a services platform that is serving up those customers and aggregators. So it may be a new platform that comes into play that we've been talking about doing in Europe and here in the U.S. So I do think that we'll see another platform in the system that is offering up those services to different end customers and aggregators.
Great. Yeah.
Because they do need to be grid friendly. You can't, you know, before when the utility was the one turning off the load, they knew what was happening in the system. You just can't randomly, you know, have everybody, some other aggregator turning on or turning off loads without understanding what's going on in the larger system.
Definitely. Arindam, you seem like you want to jump in.
And
here.
one point I will add is interoperability, right?
Yeah.
I mean, that will be a key, because I think you can have multiple aggregators. You can have one DERM vendor talking to another DERM vendor, and you know, being able to, like, for demand response, you know, being able to send like OpenADR signal, for example. I'm not saying OpenADR is the only way to go. And then, you know, at the home level, it's more about, you know, smart energy, SEP2 type of signal. So there has to be some way of consistency in these messaging structure. And this goes back to what you said, the DERMS platform, whether it's the, you know, the big guys making it or you know, like guys like you, the platform needs to be versatile enough, and it needs to be open standard based. That's critical, because otherwise you will have issues down the line.
Interoperability and flexibility, definitely. Any other questions out there?
Hi, this is Arthur O'Donnell, California Public Utilities Commission. Throughout the conference today and yesterday too, you heard references to AB 327, the distribution resource planning function, which for the first time will cause the utilities to look at storage, PV, energy efficiency, demand response, all as the same package, right, and to plan for them. What is the role of a DERMS system within this? Is it something that could be used as a tool to help us with the big challenge, which is optimizing the location of these resources, getting them to understand how they operate together in a net impact on the grid? Or is this just something that the utilities will come and ask us for money for in their GRCs after they give us the
We'll
plan?
always do
I'm
that.
trying to figure out where this fits into that.
Whoever wants to
Sure,
jump on that.
I'll take that. Seeing it's Arthur. Well, I'd say two things. One of which, it really is a management system. It's really not necessarily the management of what's out there. It's not necessarily a planning tool in and of itself. So it doesn't sit there and necessarily do a sort of what-if scenario analysis to, as I look for increased penetrations of renewables or other types of systems out there, or looking at a lot of sort of dynamics, what's going on, where would a system benefit from X or Y. I think longer term, and maybe that gets to the market piece that Ed mentioned. I'd also say that, one of the things though is that, we have, AB 327 has required the utilities in California to look at this world a little bit differently. We're now sitting there and saying, well, okay, what works where? And what would make sense where? And I think the challenge gets to be that, we are sitting, I think you heard some of the earlier sessions, some of the challenges get to be some around the ability to do some of the modeling that we need to do to get to those answers. We'll have gross answers, but we won't necessarily have really straightforward answers. I would correct one thing, we had back in the day actually had to go, and we have filed with the commission to actually look at all sorts of DER alternatives as part of the planning process. So it is something that's actually in ours today. So it is a challenge, but we view DERMS today as it exists as really the management system. Given that these things are actually going in, given that I have a choice around whether I have energy storage or I have an inverter that I can control or I have some demand I can leverage, how do I do that in a seamless fashion? And I'll try to optimize that with what's there.
And the one thing I would say there, we're working with a utility in the Northwest, and they're looking for an application that is really around planning called Valuation. And whether it's load or distributed generation, they want to understand what is business as usual if we do nothing, and then what if we take an action. So whether that's a load reduction action or a generation action, what does that mean for the customer and what does that mean for the utility? And they want to understand where the value goes. And this is a real-time function that they're asking us for, and it's not released yet. We're still working through some of the math and how they determine value and actual locational cost. But it will be a tool that will give you 4 or 5 different options, and then eventually they want to automate that and put a weight on who the value goes to, whether it's the customer or the utility, before some action is taken. So I think there are lots of utilities out there with really innovative ideas on how to help solve some of the up-and-coming problems. So I think it can be a lot of things to a lot of different utilities. And it's really understanding that customer base and listening to the utility for what their needs are and what their customer needs.
I want to get one or two more questions, but I know Adrian wants to say something. If you could just make it brief.
I would say that the DMS system implemented correctly is going to help with the inevitability that whatever plan we make is going to be wrong because we can't forecast the future. So if we make the system open and flexible and interoperable, it'll mean that whatever does turn up and whatever behaviors we do encounter from the edge of the grid, the system will flex to allow for that. And so I think that means that you can increase your margin of error in planning and still have some comfort that the system will accommodate that.
Okay, thank you. Another question in the audience?
Yeah, we heard today that DERMS can automagically handle all sorts of interesting problems in the system. I heard dealing with advanced distribution automation, microgrids, volt fire optimization. So somehow they'll automagically address all these things. For Ed and Tom, what would you recommend to other utilities who are going to? You guys are already into developing DERMS. What would you tell your other utilities? How should they go about putting together a specification, an RFP, in order to buy this magical DERMS system? And to the vendors, Adrian and Oliver, what would you suggest should be in such an RFP, such that you could deliver something that they actually can and will use?
Go ahead. I know we don't have too much time, but I don't think it would be too bad if we run a couple minutes over, but go ahead.
So from an auto magic perspective, I think we had developed use cases around very specific things that we wanted to see accomplished. I think what we're going to see is the functionality of the particular products expanding over time. I mean, I think that that's just somewhat inevitable. It's going to be a progression. It's not going to be a, all of a sudden here's the package that I buy and everything is there and it does everything under the sun, because that's unrealistic. It's sort of evolving. It's going to take some time. But I think there's very certain things that we want it to do. And when you specify what it is you want it to do, then at least you can sit there and hand it off and go look at what vendors have available for you to buy, as the case may be. And they can come back and say, yes, we can do this, no, we can't do that, or here's how long it will take to provide that functionality.
Great, Tom. And if anyone else wants to jump in briefly as we close this panel session, maybe we can close on these notes.
I'll say one point, and Eric, you probably were not there. The very first question that Omar asked us, and I mentioned to him, we are not going to finish our discussion today with what DERMS is and what DERM can do. And that is the solution that will fit everything. Because it will evolve. It's a question of what you need. As you said, you build up the requirement. It's all about integration. So the DERMS is nothing new, right? I mean, you are bringing all these different control devices in one place, making sure you have the communications established, making sure you have the data coming back, and it's that box that goes back to DMS, if you have DMS. Now, what you do with that is defined by what the needs are.
And again, I would love to jump in and continue this conversation, but we're out of time. So if we want to close off, do you guys have final 5-second comments on this discussion before we close out? Okay, so flexibility, perfect. Flexibility, interoperability, other discussion topics that, please stick around and talk to these people about. We need to talk about this and really discuss it are the, New York reforming the energy vision, ROIs, again, another thing. But for now, this was the DERMS panel at Grid Edge Live. Thank you very much to our panelists, and thank you all for attending.